In Module 3 of Chapter 13, we're going to look at the mathematics of delta hedging a little more formally. First of all, in the same way that you can approximate the change in the call price using delta, you can make an adjustment to that approximation using the gamma term. And the formula is at the bottom of the page, and here epsilon is just a change in the stock price. This should be familiar to those of you who've studied calculus. This is exactly a Taylor series. And it's a Taylor series because delta is the derivative of the call price evaluated at the stock ST, and gamma is the second derivative of the call price evaluated at ST. So one sees that this is exactly a Taylor series, nothing more, nothing less. So we can now look at how this approximation would have worked in day one, or no, this is not day one, excuse me. It's where prices go from $40 to $40.75. The call option actually increases from $278 to $324. And we can now look at the delta approximation, and the prediction would have been $321.72. Notice that the prediction is below the actual stock price. This is the convexity of the call curve, that the actual change in the call price increased more than the delta, the delta approximation called for. Now, if we add to the delta approximation the gamma adjustment, which is that term there, we see now we get a price which is increased from the delta approximation predictably because gamma is positive, and it's much closer. It's just a little bit too high, but it's much closer to the value that we actually calculate. So the gamma approximation helps, and here's a graphical depiction where, again, the tangent line, here's S0, the tangent line is the delta approximation, and then we have an error. The approximation error is here. And the gamma approximation lifts from the tangent line to basically a quadratic. Instead of using a tangent line, we use a tangent parabola. That's what the second order approximation gives us. It's putting, so the parabola picks up much of the curvature or the convexity of this function. So now the next step is to account for theta, because in the same way that prices of the call change with changes in S, they also change with changes in T. That's what theta measures. And now what we're doing is we're adjusting the Taylor series, and this is the Taylor series only accounting for S, and then we add an adjustment for the derivative. This would be what would be called a multivariate Taylor series. In other words, by recognizing that the call price is a function of two variables, S and T, there would be an associated Taylor series that reflects both changes in S and changes in T. The first part of it is the with two orders of approximation, the S component of that Taylor series, and this is the first T component. There would also be a T squared component, like the convexity or the second derivative of time, and so forth. But this is all that we'll use. And in our example, theta is defined as, is calculated to be negative 6.33. Now, we have to remember the units of theta. Because time is measured in years, this would be the change in the option value annualized. When we calculate dc dt, the units of time are years. So this 633 is way too big to be used for a one-day theta. And what we want to use in this case, of course, is theta times h. That's what we see here, theta times h. And so we'll divide this negative 633 by 365, and we'll get almost 2 cents, a negative 2 cents. And so here you see it here that the this is a for the call here, and here we're looking at two prices where stock price goes up 75 cents, goes down 75 cents. We have the 278 call starting price, and then we can look at each effect. We have a delta effect in this column. We have a gamma effect here. The theta effect is roughly 2 cents. So here we're looking at the investor's position, the long position, and for the long position, theta is negative. Remember, the market maker has a positive theta because they're short. So the long position has a negative theta. That's what we calculate. And then when we look at the prediction, that 2 cent adjustment helps out the approximation, and we can see we get quite good accuracy using delta gamma as well as theta in this approximation.